All right. I think it's about time to get started. Good afternoon. I didn't hear that. Good afternoon. That's better. All right. So I hope you had a good lunch, and now you're ready for some architectural stuff with ASP.NET Core. How many of you have been doing some ASP.NET Core stuff already? Quite a few, that's good. I think .NET Core is really getting popular nowadays, that's good. So I'm not going to be talking about any introductory stuff around ASP.NET Core. We're going to talk more about how we can build something based on the clean architectural principles. That is also a way that I build most of my ASP.NET Core projects, be that APIs, be that MVC applications, whatever they may be. So my name is Gill. I'm here for the second time, so thanks for having me again. I'm coming from Belgium, where I have my own company, Spirit, and I'm doing the CTO stuff there. You can send me an email if you have any questions afterwards. Feel free to reach out. I also post the slides on my personal website there as well. I also do a lot of Pluralsight. Been doing that for close to 7 years now, including a lot of stuff on .NET Core and also on Blazor. So my new course on Blazor will be released in, I think, 2 weeks or so. So it's going to be a full course on getting started with Blazor. So that's going to be an interesting one as well, I hope. If you want to check out my courses, that's the link that takes you to my speaker page on Pluralsight for all the courses, like I said, also including ASP.NET Core 3 stuff. So what are we going to be doing today? Actually, I have quite a full agenda, so I may not be able to fit it all in, so we'll see where we get. First, little introductory stuff, setting the scene. What are we going to be looking at? So what is ASP.NET Core bringing to the table? Where is it going to help us? That's what we're going to start with, like 5-10 minutes or so. Now, clean architecture, as we'll discover, has to do with applying a number of architectural principles. Nothing new, really. Now, I'm not sure how many of you will know all these principles, so I'm going to give you a 5 to 10 minute overview of these architectural principles that really are the foundation of an architecture based on the clean architectural principles. And I will take a look at how I built my applications. So we'll take it from layers into clean architecture, so you'll see the differences moving from the one approach to the next. We may have to skip the other part where we see how some other things are done in ASP.NET Core applications as well. But I do want to spend some time looking at how this thing is going to be testable, because clean architecture is building with testability in mind. So we'll take that into account when we do that. And I do want to show you how we can do all the testing as well. So I want you to walk out of this room after an hour with the following knowledge that you will have gained. So I want you to understand what clean architecture is and how you can apply it in ASP.NET Core applications, and also see, like I said, if we have time to do some common tasks, and including how you see that clean architecture can help you with testability and maintainability in your applications. All right. So first, like I said, a small introduction. Looking at what we need as developers to build modern applications, modern web applications with ASP.NET Core nowadays. Now, if you look at requirements that people put forward when building modern web applications, well, there's quite a few. But I think I digested the most commonly used one in this slide here. Modern web applications have to be highly available. We have to make sure that our applications are always up and running. That, of course, goes hand in hand with cloud and scalability. And scalability is, of course, the next one that is also a requirement for most applications that we build nowadays. They also have to run on any device, be that a mobile device, be that a desktop device, be that whatever. But they also have to be, let's say, hostable. You can take any device also to the server side. They have to be hostable on Linux because we move stuff into Docker nowadays. We don't do plain Windows hosting anymore. We put our applications in Docker containers, and therefore they also have to be hostable on Linux and maybe even on Mac. They also have to be highly secure. That's quite a normal thing. I would think that we don't build unsafe applications. At least I hope we don't. And also we have to offer a rich user experience. So those are the most typical requirements that web applications have nowadays. And if you look at what ASP.NET is putting forward, is bringing to the table, well, it actually, let's say, solves all these things pretty much out of the box, right? The scalability, ASP.NET Core, compared with plain ASP.NET MVC, is built with scalability in mind. It's so much more scalable because of the fact that the footprint is so much smaller. It doesn't bring all the system web stuff that it used to do. It brings only the things that it needs because it's based itself on dependency injection. And we'll see that dependency injection, by the way, is also very important when we build our own architecture based on clean architecture. It's also cross-platform, so it's going to fulfill the cross-platform, the any device requirement. It runs on Linux. That, of course, also helps with the scalability, because we can actually very easily move our application onto Linux hosting. We can move it into microservices, hosted in Docker containers. So all of that is pretty much built into the application platform. Loose coupling, we'll see that loose coupling is maybe the basis, the basis of the basic foundation, let's say, of clean architecture. And that is also built in, because ASP.NET Core comes with dependency injection built in. You can change it. It's very flexible. You can change the dependency injection system, but it's actually built into the platform, so it makes it easy for you to also adapt and start using it. It's also built, let's say, with testability in mind. It's very easy to test. We'll see by the end of the presentation that ASP.NET Core, and if you apply clean architecture principles, it's very easy to test your application. You get something like test server built in. Maybe we'll have time to look at it. So it's basically, built also with testability in mind. It also has things like side-by-side. You can do multiple versions of the application's framework side-by-side. I'm not going to talk about that. And like I said, it's high performance and optimized for cross-platform hosting your application into Docker containers, on Docker containers as a microservices architecture. So all of these things are built into ASP.NET Core. We get them for free. Microsoft has already taken care of that. Now, if you look at or what we are going to be looking at, is actually, we're going to look at principles. I'm not going to be talking too much about really the code, really, because, the code is just code, but we're going to look more at principles, how to divide your application into several parts. So everything that we're going to be looking at here today is actually going to be applied, is going to be applicable for just any type of ASP.NET Core application. You may be saying, I don't do any MVC applications anymore, right? Then you can apply these principles fully for APIs that you built with ASP.NET Core as well. So everything that we see here today applies for MVC applications, Razor pages, plain MVC applications, APIs, even for hybrid applications, and maybe also even for Blazor applications, yes and no. So it basically applies for all types of web applications that ASP.NET Core is involved in somehow. So all the principles will apply for all of these types of applications. And as a little side note, we're talking about architecture. This is a question I often get when I talk about ASP.NET Core. People or companies come to me and say, well, should we build our next ASP or next web application, let's say, as a SPA, as a single-page application? Well, it depends. Like everything in software, we cannot give a clear answer. It all depends on a lot of factors, of course. But I do see a lot of applications that are being built today as a SPA, where I think a SPA doesn't make sense. There are a lot of applications that, like blogs, maybe web shops, content delivering websites, web applications don't make sense really to build as a SPA all the time. And if the team has little to no JavaScript experience, it's very hard to get the team up to speed with the fast forward moving landscape that you have with JavaScript. So it doesn't always make sense, right, to do a SPA. But let's not go too much in there. But like I said, everything that we see here today can be applied if you build a SPA with Angular, with Vue, whatever technology you want to use. Everything that you see here will be applicable for an API as well, right? So all these principles are fully applicable there as well. So my advice in that area, build a SPA, build a web application that has a rich front end if you're building a web application rather than a website. Right? It's something that there's a clear division between the two, and it doesn't always make sense to build a SPA. It's not because your neighbor is doing it that you should also be doing it. Now, of course, this is the new kid on the block, right? Who's been playing with Blazor? Few people? Only a few people, right? Cool. So I assume that you know what Blazor is. It's going to be the big thing coming out. It's actually already out as a server-side version, but the client-side app version is coming out next May. It's going to allow you as a developer to just use C# in the browser, talking with an ASP.NET Core backend. So it's going to be C# all the way, right? And again, everything that we see here today in this presentation can again be also fully applied when building Blazor applications, right? This is definitely for 2020 the thing to invest time in, because it's going to make you as a C# developer capable of building rich web applications that run fully on the client, even with offline capabilities and so on. So if you don't like JavaScript, 2020 is going to be your year, I think. Right. So enough for the introduction. I'm going to show you everything here today based on a working application, because like I said, we're not going to spend too much time looking at code, we'll look harder at principles. The application that I use for this, if my mouse, there we go. So the application that we'll be using is an application built by Microsoft, because they also know how to do clean architecture, that's good. It's called the eShop on Web. They apply some principles I don't really like, some things I don't really like, I'll point them out. But this is an application you can find, eShop on Web. You'll find it at microsoft.com/net/architecture. And like I said, they apply most principles very well here. So we'll use that as our guide to look at how we can do this in ASP.NET Core. Now, I do want to show you the finished application to give you an idea what we're looking at here. It's a web shop, right? So you can click on a product, you can add it to the basket, and there we go. Visual Studio stopped working. Very good. Thank you, Visual Studio. Yeah. So it's a web shop, right? A web shop stops now and then. So we'll see what it does now. I did order a new machine, so I think my machine is actually getting a bit jealous. So there we go. So let's try that again. It was a fantastic demo. If it takes too long, we'll already go on and taking a very long time. There we go. So we'll add to the basket again, try that again. There we go. So now it seems to work, very good. Then you see the basket, you can increase the number of items. I don't think this is real rocket science, you're all smart people here. So you can then check out, you can log in with the user. There we go, because you're not logged in and your order has been placed, right? So, like I said, this is not really relevant to what we're going to be talking about here, but you do now know what we are looking at in terms of functional design, what we're looking at. All right, so, there we go. So now setting the scene has been done. We've already lost 10 minutes, so I need to hurry up a little bit. So now before we look at clean architecture, I do need to give you a little overview of some of the most common patterns, or actually I should say the patterns that clean architecture is built upon, right? So clean architecture, as you'll see in 10 minutes or so, is really nothing new. It's really applying a couple of patterns in a good way. But I do want to give you these patterns as well, because you may not know them, and then you may actually get a little bit confused, right? So these patterns are nothing new. They are actually things that you probably already know and hopefully use, but I do want to give you a small overview of these as well. These principles are there to get us into an architecture that is going to be three things, basically: testable, maintainable, and loosely coupled, right? That's basically what we're aiming for with a good setup in terms of architecture for an application. The one basically brings along the other. If an application is testable, it typically means that it's maintainable, and it's probably based on loosely coupled code. Because if you do tight coupling, you have hard links between all the components, and therefore your application is probably difficult to test, because if you need to test A, you're going to have to bring in B, and B brings in C, and so on and so on. So the goal is bringing up or setting up a maintainable, testable architecture that in the end is easy to test, and we'll see the unit testing at the end of the presentation. So, like I said, a number of principles, a number of architectural patterns make this possible. Like I said, these are not rocket science. I hope that you know all of them. If you know all of them, very good. Then you can rest for 10 minutes or so. If you do not know all of them, please pay attention, because like I said, you're going to have to apply them when building clean architecture into your applications. They are separation of concerns, dependency inversion, explicit dependencies, single responsibility, the dry principle, the bounded context, and persistence ignorance. So like I said, I hope they're not anything that you've never heard of, but let me give you a small overview of all of these in a bit more detail. And we'll start with probably the most important one. No, not the second most important one. And that is the separation of concerns. I do hope that separation of concerns is something that you already know about, because it's something that every software developer should know, even if you haven't been around in the software industry for too long. So separation of concerns is basically saying you are going to split up your application into different blocks, and each is actually going to do a specific thing, right? When you write code, you don't want to put every line or put all the functionality into one big bucket. You actually want to split it out, because, of course, otherwise it's going to be hard to test things in isolation, right? You actually want to, you don't want your UI to actually dive into your business calculations and then also go out to the database. you don't want to put that in code behind. That's how we did things in the 1990s. That's not how we do things anymore nowadays. So we actually have to split things out a little bit more. That allows us to test things in isolation and actually make sure that we only focus on what we want to test. So the business logic layer is a good example, the data access layer. They know about each other, but they actually do their thing and their thing only. That's pretty much the thing that you're going to do. If you've been building applications in layers, which I hope you have done so far, well, then this is pretty much it, right? That's separation of concerns. You can also do that on a different level, on a class level, and then it basically comes more into the single responsibility pattern. The single responsibility is very close related to what separation of concerns is saying. They're not exactly the same. Single responsibility is more on an object orientation level rather than on an application level, so to say. But single responsibility is basically saying in object orientation, sorry, a class is doing one thing and one thing only, right? And if I need to change the class, it should be because I need to change one thing, and if I have to change it for two things, well, then basically I need to split it in two things, in two classes, really. That's single responsibility. Again, something that you probably already apply, hopefully, because it's basically saying if you have a class, it shouldn't be doing A and B and C, because each a class should be doing A and A only. And if I need to bring in B, then I need to bring in a new class, and I need to bring in C. Classes don't cost a thing, right? You don't have to pay Visual Studio every time that you create a new class. That would be horrible. So that's why you can create more classes with their own functionality, and that's what single responsibility is saying. Now, when you apply this on an architectural level rather than on a class level, you basically are also saying, my data access layer is going to do data access only. It's not going to do business rules. My business layer is not going to do data access. That's pretty much the same thing. But you can also pull that into an even higher level. Think of microservices. Microservices are actually also applying to single responsibility pattern, but more on a functional level then. They should do one thing. For example, if you have a microservice architecture, you could say, well, that microservice is doing customer management, and the other microservice is doing product management, and so on. So they all have their own functionality, their own single responsibility, and that's basically what this pattern is saying. The third one is, that's my number one, really. I think that's the most important one. Dependency injection / dependency inversion. Nowadays, dependency injection is something that most people know, hopefully, but I do come across companies where it's not really known and not really applied, and they think it's something very high up in the sky and very complex to understand. Well, it's definitely not. What you rather not want to do is have, at compile time, references between your components. A should not be referencing B directly, because then you create tight coupling. And if B is doing the same with C, well, sorry, it's not going to work. Because if you have at compile time and runtime dependencies are fixed, then your application becomes by default harder to test. Dependency inversion is going to say that the dependencies should point in the direction of the abstraction. So basically what you're going to do, you're going to bring in interfaces, abstractions, that are going to be on top of the B and the C, for example, here. So the A is not directly referencing B, and B is not directly referencing C. Rather, they will work with the interfaces at compile time. And through dependency injection at runtime, they are actually going to be fulfilled. So you see there that A is referencing the interface of B, and B is referencing the interface C. And at compile time, they don't know about each other. They don't know about the concrete types. They only know about the interfaces, about the abstractions. Yeah. On the right, then you see at runtime, it's still the same. A knows about B and B knows about C, but that's dependency injection is actually going to help us resolving these dependencies. And like I said, ASP.NET Core, for the people who have worked with it already, it is built into the platform. Please use it. Don't start creating hard references. Put everything in a dependency injection container. It's going to make your life a lot easier. And you see that that's being done in clean architecture all the time. Also, be explicit about your dependencies. This is a smaller one, really. Explicit dependencies means that your components should say what they need. I need this and this and this dependency. So they should be actually doing that typically in the constructor. Constructor injection is therefore a result of that, more or less. So explicit dependencies basically says if a component needs different dependencies, it should say so. Rather than having, for example, properties that are needing to be fulfilled by dependency injection, it's much harder because you don't know if your application is going to work. You have to go and do null checks and so on. It actually leads to less readable code. This, like I said, is a smaller one, really. Don't repeat yourself, right? Don't repeat yourself. Sorry, I did it again. Stupid joke. So the dry principle, again, is something that if you apply layering today, you probably are already doing. You shouldn't be writing the same code twice. because then you actually have to maintain it. It's harder for maintainability. You have to do it in 2 places, and you probably will forget the second one if you do it in 1 place. So make sure that your your code is in 1 place and 1 place only. And layering, like I said, brings this. If you have UI and a data access layer and a business logic layer, the data access will do, or the data access layer will do all the data access and can be accessed from anywhere to do that. Right? That's again a very simple thing. And again, this is persistence ignorance is a little bit related to that one. It basically says don't go out and create your domain based on whatever framework you're using to do your persistence, right? If you think back of entity framework in the very, very beginning, you didn't have the ability to do POCUS like you have nowadays. You actually had to build in, or bring in that base entity, I think it was called in the beginning, in the very first versions of entity framework. That's not good. That's not clean code, typically. If you actually start making your code littered with dependencies on a framework, it's actually bad. You may be saying, because typically this is where people say, yeah, but maybe some point in the lifetime of the application, we're going to switch it from SQL Server to Oracle. Who would do that? But anyway, that is not typically the problem. But if you make your dependencies, your entities dependent on a framework, like I said, database switching is not something that I've ever come across in an application's lifetime. I do have seen that, for example, we build the application today, we build it with a clean domain, clean POCUS, and tomorrow we start using Redis. And then of course, if you have a dependency in your domain objects on a framework, it becomes harder because Redis then needs to accept these entities as well. So make sure that your domain, your entities, does not know about any persistent store. It should be clean. It should be handled down the line. Yeah. This is something that I've come across quite a lot. We build the application today, we use SQL Server, and maybe tomorrow we put it in Redis. And then, of course, things can work exactly the same. The application is ignorant about the persistent store. And that's, not, of course, very good. And then finally, bounded context. This is something that you may not have applied, even if you've been building software for a long time. Bounded context is basically something that is more commonly used in combination when you apply or with DDD, so domain-driven design principles. I'm not going to be using, because clean architecture, by the way, is also very commonly associated with DDD. I don't have the time to explain you also DDD in 50 minutes, then we have to do another hour or so at least. But bounded context is a pattern that you see often being used in combination with DDD. And it basically says, from a functional perspective, you will divide your application into several functional blocks. That's what you're going to be doing in that case. So basically, like I already said, customer management is one part and product management is another part. That's basically what you then are doing. And so the functionality, each maybe with their own data store, becomes like a mini application and a mini bounded context. And I know I'm not saying it 100% correct, but that's basically what the principle is all about. This is also used in combination with microservices architectures, because then each microservice becomes its own bounded context, again with its own data store. It's like vertical slicing through your application. And the product management becomes one part, the customer management becomes another part, and each of them becomes its own microservice. So, with that out of the way, we are pretty much on time actually. Very good. I'm keeping my timing. Very good. That's the first time. So, with that out of the way, you now have pretty much all the knowledge you need to understand what is in clean architecture. So I think the next thing is, because you of course came for clean architecture, to see how we can actually move into building applications with clean architecture. Now, clean architecture, like I said, is nothing complex. It's nothing to be afraid of. I'm going to show it to you step by step. I'm going to show you how you can actually go from an application that is today maybe built with Founder Project and boom, everything on one pile, into clean architecture. So typically, when I visit companies, I see, let's say, there are 3 possibilities. And you typically don't see clean architecture used all that much. You see a lot of applications being built all in once, layers, and then I will show you how clean architecture can actually be a little bit better. So let's start with all-in-one. Now, what is all-in-one? All-in-one is typically, there we go, is typically the result of a manager saying to you as a developer, I need a small application that we're going to use it just a couple of weeks, and then we're going to throw it away. And after a couple of months, it's still there, and after a couple of years, the entire business runs onto it, right? Familiar? Yeah? Okay. That is typically your monolithic application. The developer says, okay, I'll do file new project, and I'll throw everything in one big pile, and yeah, it's going to be thrown away anyway, so it's never going to be thrown away. But then you actually get an application that is fully self-contained, typically one project, one DLL. It's a monolithic application. And technically, there's nothing wrong with a monolith, because you can still do everything correctly, you can still do testing and maintain, but it might not be the best solution in the long run. Because think of if you have to deploy that monolithic application into Azure, how you're going to do that? Well, you have to basically take the application and you're going to scale it, and we're going to put a second server and a third server and so on and so on, right? That's what you end up with. Because typically things are going to be monolithic, you can't pull them into different parts. So this is a screenshot of a small monolithic application. I'm not sure if it's readable in the back, my apologies for that. So basically, file new project, and then you start adding classes and controllers and view models and I don't know what in that one big project. And it starts growing and growing, and it becomes hard to find just anything in there, right? Because you have lots of controllers, lots of views, lots of view models, and that sort of thing. And maybe at some point you say, well, I'm going to move my classes or my domain into a separate assembly. It's not going to help you, right? You're still going to have one big pile, one big chunk of code that's all very tied together. And that's not typically what you want. You do get a little bit of separation of concerns, if you can really call it that. You're going to create, hopefully, different folders. It might be separation of concerns, because then hopefully you put the controllers in the controllers folder if you do controllers. Actually, I've seen places where they don't do that, but anyway. Like I said, it's not an ideal situation to be in the long run, because it actually, although you do separation of concerns by putting things in the correct folders, it's going to be hard to find something. No one is really applying, or let's say the architecture is not applying that you actually use all these architectural patterns, because you can put everything everywhere and no one is really looking at it, and Visual Studio will still compile the application and it will still run, hopefully, but that's not what you want to do. So let's forget about that. Let's not go into that area. So you probably have been taught since you started developing, you need to build your application in layers, right? Who's been doing layers? Most people. That's what you've been taught in school and at the first job and the second job, because we all do layers, right? So we build a lasagna of layers. That's pretty much what you do. It's good that I don't do this for lunch, because then everyone would run out. So why do we do layers? Well, we actually want to apply separation of concerns. We want to diminish the complexity of the application. And we actually start splitting up, because the UI code needs to go there, and this is the business layer code, and this is the data access code. So it actually is going to be split up according to concerns. That's good. We're going to apply separation of concerns. Again, like I said, there's nothing wrong with layers. Don't get me wrong. It's going to be easier to find your stuff. It's going to be, you're actually going to apply the dry principle, because you're going to build a layer that does just the data access, and you're actually going to make sure that the code is going to be reusable, because all your business logic can actually use something of the lower end, and your UI can use business rules which are in the business layer, and so on. So technically, it's okay, right? If you need to replace something, you only have to replace it in one place. That's also good. So a lot of benefits come from applying layers. It is already a bit more loose in terms of coupling. You can do dependency injection this way, of course. So again, like I said, this is already a very big step in the good direction. Now, so this is what you typically do. From a very high-level perspective, no matter how many layers, because sometimes you have a facade in there and so on and so on. So just from a high level, you have your UI that talks with the business layer and that talks with a data access layer. Pretty much it, right? Each layer has its own responsibility. So single responsibility has also been applied, so that's good. Now, if you think of it in a bit more detail, well, the problem is that this thing is actually, although I've split it up in layers, I still have the problem that there are some issues in terms of, for example, deployment. If I want to deploy this type of application, I cannot say, I'm going to put the data access layer on that server and the business layer on that server. It's going to be really hard, because technically, what you have created, although you have split it in layers, you still have the hard link between the different layers, because the data access, the UI still references the business layer, and the business layer still references the data access layer. Technically, the business layer cannot exist even without the data access layer. It's typically still a hard link. So you have what is known as transitive dependencies. You basically still have dependencies between the different layers. And like I said, it's already a bit more complex than what you have created. So while there is nothing wrong with this approach, so this is what you then have. You have the different projects in Visual Studio. The business logic becomes one layer. The data access logic is a layer, and the UI is also another layer. In terms of deployment, layering typically, like I said, doesn't really help you. Layering is not going to allow you to all of a sudden say, hey, I'm going to put this on that server, the UI on that server, and the business layer on that server. No. And by the way, clean architecture is not going to guarantee that you're going to be helped in that area as well, but I'll come back to that. But so in general, although you have layered your application, the application is still going to be typically deployed as one single unit. That's not going to be solved by just doing layering into your application. So from an outside, they're still the same. You have one application consisting out of several projects, consisting out of several layers, that is. And you actually, when you want to scale them, you're still going to have to copy the entire application onto different servers and put a load balancer in front of it. And basically, that's, like I said, that doesn't really help you in terms of scalability and deployment issues. So there's still a full copy, let's say, running of the entire application on each and every server. So in terms of, if you want to move into container-based solutions, layers are typically not going to help you, because you cannot, for example, say, hey, my UI needs more capacity than another layer. That's not possible, right? So you typically will have to build your entire, or put your entire application into a single container and then duplicate that over multiple container instances. So typically it's not a very good approach, because you might actually choke the application still on one particular piece, right? Docker or containers in general and a microservice-based architecture is then basically going to say, well, I, for example, my functional split, so vertical, where we have the catalog, for example, is going to be a different microservice, which can then have its own layering applied, and then the shopping basket, for example, is another microservice, and I'm going, when I have a lot of load on the backend, sorry, on the website, we're actually going to scale up just the catalog controller, or the catalog microservice, and then that's basically what you want to be going to. Again, layering is not going to help us in terms of deployment. All right. So that brings us to, well, like I said, layers, nothing wrong. Right? Don't stop doing it if you do it today. But I'm going to show you how clean architecture is doing things. So it's a little bit different. So keep in mind, UI, business layer, data access layer, that's what you typically have. In clean architecture, we're going to turn things around a little bit. So, by the way, clean architecture is nothing new. Like I said, it's not the holy grail. It's not something new that I or someone else just invented. It's typically applying a lot of good architectural principles. And there's also a number of variations of clean architecture that you find. There's actually, sometimes you see ports and adapters as the name. You see hexagonal architecture, onion architecture, and that will become clear why in just a second. So this is pretty much always the same. There's some minor differences between how they are applied, but in general, it's pretty much the same thing. It's always pretty much the same thing. And again, also, it's often used in combination with DDD, but it doesn't have to be used in combination with DDD. So you don't have to start doing DDD because you start applying clean architecture. All right. So in clean architecture, what we're going to do is we're going, like I said, turn around the dependencies between our different layers. Typically, we start with, in clean architecture, what is known as the application core. And in application core, you're going to have your domain, your entities, and services, interfaces. And that's what is going to be at the heart of the application. The core is typically what you do first, and it has no dependencies whatsoever. That means that you can do whatever you want in there without being disturbed, let's say, by external influences. On the other hand, in what we're not going to be doing anymore, so your core could actually be, let's say, compared with your business layer. In this case, typically in a layered architecture, your business layer is dependent on the data access layer. In this case, we're going to turn things around. Like I said, my application core is not going to have any dependencies anymore. The data access layer, in turn now, is going to be or become dependent on the application core. So we're going to turn around the dependency. And so what this results in is the following. What you see here is This is also why it's called onion architecture. A little overview of how the application architecture is going to be set up. At the core of the application or the code is actually your entities and interfaces, lots of interfaces. Hence, you also need dependency injection to later on plug in the concrete instantiation. So you're going to put in entities and interfaces at the very heart of the application. That's the thing in the very middle. And then still in the application core, you're also going to write your, whatever you call them, domain services or application services. So basically all your business functionality, you're going to put in the application core. That's the orange part. Together, that's the application core. And that, as you'll see in Visual Studio in just a minute, will have no dependencies on anything external. We're turning things around. We're actually going to bring in the dependencies into the application core. We're going to make our dependencies point towards the application core. So that means that the infrastructure, which is typically a project that does data access, logging, file access, maybe whatever you want to do, is actually going to point towards the core. That's what you see here at the bottom. You see that little arrow? It's not really visible, I hope. The blue arrow actually points into the application core. The UI, same thing. The UI will actually be dependent on the application core, right? So we're going to turn dependencies around. You may be thinking, how am I going to apply that? Well, I'm going to show you in just a minute. So basically, I've mentioned this already, yeah? Okay. So if that circular thing is confusing you a little bit, this is actually the flattened circular thing, more or less, to give you a more comparable view compared to the typical layered architecture. So what you now see is that at the very bottom is your app core. Again, that's the thing that was originally in the middle. And your that has no dependencies. So your business layer that we had before has no more dependencies. We'll actually have our UI be dependent on the application core, and we'll also have our infrastructure project, infrastructure layer, be dependent on the application core. How is this working? Well, actually through interfaces and through dependency injection. We'll actually plug the concrete instantiation of the interfaces defined in the core into the core at runtime, so the core can do its thing. And it's all, like I said, built on the concepts of dependency inversion. This is a more extended graph. I think it's something that I stole from Microsoft at some point. Don't say it. It's recorded. Anyway, so what we have here is pretty much the same thing. You have your application core web. That's the website. That's the UI. And the logic, the core is at the bottom here. That's the red one, if it's not readable. And the green one is the infrastructure. Whom is dependent on who? Well, the blue one, the UI, and so you see that that might not be readable. So the dotted arrows are compile time dependencies, and the full arrows are runtime dependencies. So your application core will actually have a compile time dependency and a runtime dependency on the application core. It will need to know about it. However, your application core has no dependencies on anyone else. Your infrastructure, so your original data access, now has a dependency on the application core. And through dependency inversion, we'll actually resolve this dependency in just a minute. Why is this useful? Well, because your core is going to be, like I said, independent of any framework. And the principles that we're seeing here are fully applicable for ASP.NET Core, MVC, APIs, even for other non-ASP.NET Core projects, because it's just principles rather than something concrete. But I'm going to show it to you with ASP.NET Core. It's also fully independent of the use database, because, like I said, your bulk of your code is actually going to be in that application core, and it's going to be fully agnostic to whatever data store you're using. Think back of persistence ignorance. We want to have our application completely ignorant about the data store we're using, and this is fully possible with this approach. It's also fully independent of the UI. Again, most of your code is going to live in the application core, and it's not going to care about the UI that is actually sitting in front of it. And perhaps most important, this is going to make your life easier, because it's going to make your application much more easy to test. Now, before we look at the demo, quick summary of who goes where. In your domain, in your application core, you put actually most of the code in a real-life application, at least. You'll actually put your entities, so your domain, you'll put in there. You'll put services that work with those entities in there. You'll put a lot of interfaces in there as well. But you'll also put things like custom exceptions. If you actually are applying specification pattern, you can also put those in there, because everything that is fully agnostic about the actual infrastructure is going to be placed in here, right? That's the goal. Very importantly, your core should never have a dependency on infrastructure. If you see doing that, someone doing it, it's actually directly doing it wrong. Visual Studio will actually help you a little bit because you cannot create circular references, because if your your infrastructure is dependent on your application core, the opposite is not possible, right? But in general, you could actually add a third project and do like this type of references. It's not possible. But it's technically possible, so it's not something you want. Your core, no dependencies. If you see dependencies in there, you're probably doing it wrong. Second layer, to call it a layer, is the infrastructure. That's where you put all the things that are dependent on external stuff. So data access, file logging, if you need to interact with Twilio to send SMS, whatever, all that stuff goes in that infrastructure project. And the third one is then the UI. Basically, whatever you want to use, MVC, Razor Pages, APIs, whatever, that's basically your UI layer that's going to rely on the stuff that is in application core. Technically, you should have a dependency between your UI and your application core, and you may not need an a dependency between your UI and your infrastructure. If you just in ASP.NET Core today, you will need it if you use the built-in dependency injection system. I will show that in the demo. So let's actually go to Visual Studio now, and let's take a look at how this is applied here in code. So if we go to Visual Studio, you actually see under the source here, let me make this a bit bigger, that there are 3 projects: an application core, an infrastructure, and the UI, so the web application, right? So what you'll now see is that, let's start exploring. Let's take a look at the dependencies. Like I said, you should not have any dependencies in here. If you see dependencies on Azure frameworks, if you see dependencies on EF Core whatsoever, shouldn't be in here. Then someone actually crossed the border and actually did something that they shouldn't be doing. You can slap them. Say that I've said it. So there's nothing in here. So there's nothing that has to do with dependencies. There's just a small framework to do some guarding, but that's okay, right? So everything that has to do with external influences shouldn't go into the application core. So what is in here? Well, your entities. So over here, plain entities. For example, the catalog item here. That's a plain class. It has a base entity. The base entity is just an empty class with the ID property in there. So it's not a real framework-dependent thing. And also what you see in here are aggregates. Aggregates are also being used sometimes. Aggregates, if you have entities which shouldn't be used standalone, let's say, and you're going to build them as aggregates, you can also put them in here, because that's still part of the domain, really. Secondly, interfaces, lots of interfaces. Typically in a real-life application, you'll have tons of interfaces, because everything that your application needs to do needs to be described by an interface. And only at runtime will these interfaces be resolved. Yeah? What you see is that you have a couple of types of interfaces. Over here you see, for example, I think there's actually one in here. Yeah. So you see here that under services, we have basket service, and we also have an interface iBasket service, right? Because the basket service in itself is a domain service. It's actually a service that does business rules and maybe calculates something in the basket and that sort of thing. So that's actually stuff that can live directly in the application core. But you also see under the interfaces that we have the iAsync repository. And that is actually not going to be implemented in the core. It's going to be implemented later on in the infrastructure. But you do need the interface here. For example, if you go and look into the basket service, you'll see that it has, in fact, a dependency on the iAsync repository. We don't resolve it. We only resolve it at runtime through dependency injection. So this has a dependency on the iAsync repository implementation. If that's going to be EF Core, fine. Is it going to be something else? As well, that should be okay as well. So if you look at the iAsync repository, for example, this does some basic stuff like adding entities, getting entities, so typical repository stuff. So that is in here. So a lot of interfaces, sometimes things like exceptions, those can also go in here because they need to be thrown by your business, your application core, rather than your infrastructure. If you then look at the infrastructure part, you'll see, typically, in a real-life application, many dependencies, things like EF Core, identity, that sort of thing, all going to be in here, right? So all that stuff is going to be directly referenced from your infrastructure layer. And your infrastructure also, if you go and look in projects, is going to have very importantly, a dependency on application core. Why is that? Well, of course, for example, it needs an it needs to do an implementation of the iasync repository. That's why it needs to know about your application core, right? So we actually write the implementation of the iasync repository directly into this infrastructure layer, and at runtime will the infrastructure layer be plugged into the application core, and will it be resolved through dependency injection? That's what we're going to do. So we can develop the entire application core without being bothered, let's say, by any infrastructure stuff. All is going to be kept inside of this project in a nice and clean way. There's other stuff in here like the order repository and that sort of thing, and also implementations of services. There's just one here, but think of a logging. A logging is in there as well. This could be an implementation of an SMS sender, an email sender, that's something that uses Twilio or something. All that stuff can actually live directly inside of this infrastructure. So as soon as it goes outside of your application's domain, well, it actually typically will go inside of the infrastructure project. And then the last one, the website, the UI of the application. The application itself, the web application itself, technically should only have a dependency on the application core. And I mean technically, not really technically, because technically it needs two dependencies. So if you look at it from a clean architectural point of view, you should not directly reference most of the time the infrastructure project. Why do we need it here? Because of the way that dependency injection in ASP.NET Core is set up. ASP.NET Core uses dependency injection in its startup, where it actually goes through the list of all services, as you can see here. For example, the iOrder repository and the order repository, the iasync repository is in there as well. So all the implementations that are built into the infrastructure are referenced directly from the startup. That's why you actually need a reference to the applications, to the infrastructure project from the web project. So typically you wouldn't need it, because in fact your application's UI should only know about the application core, and the infrastructure stuff is going to be plugged in at runtime. Now, before I continue, and I still have, so I'm going to, hopefully you don't mind, I'm going to go like 5 minutes over time, so I hope you don't mind. Now, how are we using the application core from the website? I haven't shown you that, but things like the controllers, like I said, be that APIs, be that MVC applications, they will need to access your application's core at some point. They will need to access the business logic. That's quite normal. What I do see, even if I set up applications built on clean architecture, I still see developers writing tons and tons of code in applications controllers. Right? I'm not a fan of that. I don't like it, because applications controllers, they're like traffic agents. They should say what should be done, but they shouldn't be doing it themselves. They're managers. They don't know what to, they know what to do, but they don't know how to do it. That's why they ask you to do it, right? That's what a manager is all about. So controllers is the same thing. They shouldn't be doing too many things. They should say, well, now we need to do this, but they shouldn't be doing it themselves. If you make controllers too smart, you're again going to make it harder to test. So you see a lot of people doing actually everything directly in the controller. Like I said, not something that I prefer. A better solution is using some type of service in the UI, a view-only service, let's say, where you actually have the logic built into a separate class that lives inside of the web project, that then can in turn use the application core. So you make your controllers contain less code by default. Maybe the best and cleanest way is actually using a more command-based approach, where you actually use something that is built on the principles of CQRS, where you actually create, or you create an object that basically contains all the information about what needs to be done, and you then throw up that object basically, and someone is going to handle that. And then you make your controller completely agnostic of what needs to happen. Yeah? And that can easily be done through a framework, for example, Mediator. If you have ever heard of it, written by Jimmy Bogert. A very nice framework that does exactly that. You write an object that says, well, this needs to be done. We need to create an order. So we throw up all the information about the order, and it's going to be handled automatically by something, by a handler, basically. And that's all handled by Mediator. So let me show you that, how we can do that. So I'm going to show you first, if we look at the controllers, you'll see here that there's a couple of controllers in here. I think the order controller is, it's an API controller, doesn't matter. This is a good example of a controller that already does too many things, right? It goes out to the repository, which, by the way, in my opinion, should not happen. This is one place where I actually don't agree with the way that it's done here. I would actually do this directly on the application core and let the application core do this, right? So that also avoids direct references into the over the repository in this case. So. But anyway, what you see here is that's in my opinion, there's too much code in here, right? So you actually do all that stuff inside of the application's controllers. That's probably not the best place to be in. A better solution is, I think it is under the catalog controller. Yeah, the catalog controller, as you can see, it's also an API controller, but it's already doing a lot less inside of the controller. It uses a view service, a class that contains the code that originally was inside of the controller, but is now only being fully managed inside of the application's web project. So this catalog view model service is just a class that actually does all the interaction again with in this case the repositories and returns view models, right? So it's cleaner already. Your controls become less burdened by all the stuff that needs to happen. A third and final approach is what I just said, is when you actually go through, for example, Mediator. There we go. So in this version of the application, and it's not loading the application, there we go. Oh, something went wrong here. So in this version of the application, there we go. So what we're going to do, so this is based on Mediator, and it's actually going to create objects that contain what needs to be done. For example, this application is using a feature-based approach, as you can hopefully, you cannot see that. So you see here inside of the Solution Explorer that the application is now built into features. And so we have a feature, for example, to work with the orders, to get my orders. That's a particular functionality within the application. And there is an object, a class, that defines what needs to be done. And for example, I need to get in a request for getting my orders. So all the information to get that information is created inside of this get my orders object. And this is actually used from the order controller. That's a very good place to use this from. So you see here that we have, again, that same API controller, but now, instead of having a view service, we don't have any tight coupling anymore. Rather, we have an object that contains all the information about what needs to be done. That's the get my orders object. It just contains the username. That's okay. But it will actually send, or it will actually use the mediator as a messenger. So we throw up that object, so we throw that in the air. Mediator will pick that up, and it will automatically be handled by this get orders handler that you see over here. Right? You see here that there's an object, get my orders handler, that is going to be, in a loosely coupled way, handle, the handle method is going to be called automatically. It's going to handle automatically the get my orders request, and it's going to send back, in this case, an enumerable of order view models. And that's, in my opinion, a very clean way not to create any tight coupling between the different components. So, the last thing I want to show you, because this is what we set off with. So this is hidden slides, right? Don't start laughing. I can actually continue for another hour, I think, but anyway. So the final goal with this is this now testable, right? Can we actually easily apply different types of tests? Can we write, or can we test what we've set up in unit tests, in integration tests? Well, let's see. Let's see how ASP.NET Core handles that. So let's go back here into Visual Studio, and let's take a look at the test folder. Like I said, you can download this code from the Microsoft.com website, and I'm not going to show you all the different types of tests which are in here. But let's, for example, take a look at the unit tests. So the unit tests, let me quickly jump back to my other branch. One second. There we go. So you see here that there's actually application tests, unit tests, sorry, for the application core. So there's unit tests for the entities and for the services. Let's take a look, for example, at the services. The reason that there's tests for the entities is that because sometimes the entities also have a little bit of functionality in them to for example, check something onto the entity. I'm not going to show you that, but let's, for example, take a look at the basket service tests. So what we want to test is functionality in the application core, right? So in this case, we're going to test the deletion of a basket, something that lives directly in the application score basket service implementation. So we're going to test it. But as you can see at the top, that thing has a dependency, that service has a dependency on the iasync repository. So what we're going to do here is very easily bring in, this is using the mock-U framework. It's going to create an implementation, a mock implementation of the iasync repository in basket. It's then going to create a new basket itself over here, because we're testing, in this case, the basket service, not the basket. We're going to bring in 2 items into the basket, and we're going to use, again, the mock-U framework to make sure that that method is known to the mock-U framework, and then we're going to invoke the basket service. So as you see, by splitting it up, it's actually very easy to test these services in isolation. It's actually possible to bring in mock versions of the repositories to make sure that you can easily test your application core services in this unit testing part. And so with that, I'm already over time, so I am going to let you go further. So I hope I've given you an overview of both ASP.NET Core, very briefly. We didn't look into detail about ASP.NET Core, but I hope I've given you some food for thought to think about how you set up the applications architecture. Clean architecture has helped me quite a lot. And I think it will help you as well into building applications that are much more maintainable and testable in the long run. It takes a while to get used to, because there's a couple of things that have turned around compared to what you've been maybe doing for years. But I guarantee that in the end, it's going to make your application and your application's developer life a lot easier in the long run. I hope you enjoyed it. Thanks for being here, and I hope you enjoy the rest of the conference.